Hello everyone. So in today's video, we'll be studying about states and properties of matter. So let me quickly take you through the pages of Cambridge Science textbook, followed by my explanations. So here 3.1 talks about gases, and what are the different properties of gases, how it can be compressed, where are gases formed, and gases also causes pollution. And in the atmosphere there are different layers which has different types of gases around it, and some gases are visible, some gases are invisible. So these are the basic facts about gases, and followed by some experiments. Now here, this is a particle model of matter, and this is a very important concept that one should understand. So in my video, I'll be explaining everything using particle model of matter. Next is air and the pollution that it causes. Coming to the next topic, that is properties of water. Again, just like how we did properties of gas, we'll be doing the properties of water. Things that we'll consider would be expansion, steam, temperature, boiling point, melting point, contraction, etc. So water changes its state, we are all aware of. It can either change into solid or it can change into gas, provided we give them the suitable temperature. So melting and boiling points is something that we need to look carefully into. And next is again boiling point, melting point that they're talking about here, followed by some experiments. And this is how water change its form during expansion and contraction, which has to be explained using particle diagram. And next, 3.3 talks about evaporation and condensation, and one should be aware of all the different terminologies like condensation, evaporation, precipitation, reverse, and water cycle. So basically, this chapter talks about evaporation and how it takes place, then condensation and its usage, its application in day-to-day activities, and followed by some important keywords that you as a science learner should be aware of and start incorporating it in your explanations. So this is water cycle. That's definitely I'm going to teach in depth. And next comes 3.4, which is solutions. What are the solutions? What is dissolving? What are solvents, insoluble substances, water pollution, and then pesticides, then how it looks like, when we dissolve two items together, and how can we separate the solution, and will it be a reversible or an irreversible process? So that's all that is included in this chapter. Let me quickly take you through my notes. This is exactly how my notes look like, and while I'm explaining it to my daughter. So I am going to quickly explain it so that this video is finished in 20 minutes and it acts as a good revision for you before exam. So I'm going to use a black pen and talk about the particle model. So we all know that the states of matter is present in three forms: solid, solids, liquids, and gases. States of matter: solid, liquid, and gas. So if I draw the particle model, all the atoms are tightly packed. There's hardly any space in the particle model of solid. Whereas if I draw liquid, there would be some space around it. And gases, they have a lot of space. Now I will enclose it in a box so that it gives you a proper, um, analysis and proper visualization of how the atoms are packed. Now, since I am starting with solid, let's do some properties of solids. So solids have fixed shape, okay, and size. And they cannot be compressed. Now, why do I say they have fixed shape and size? As you see that all the atoms are so tightly packed and locked together that, they will have a fixed size and shape, because the atoms have no space to move around. They cannot just move around. So that's why they have fixed shape and size. And next, if I talk about compress, can you compress the atoms in the solid? No. So solids are incompressible because there are no space for the atoms to move and be compressed. Next, if I talk about liquids, liquids have some space here as compared to solids, so they can move freely. And that's why liquids flow, and that's why they take the shape of the container. They take the shape of its container, and somewhat I can also say that they can be compressed. Next, if I talk about um, just a second. Next, if I talk about gases, how are gases different? So when we see the gas at a particle model, there are a lot of spaces around it, and that's why gases can be easily compressed, and they are free flowing. They free flow, and they cannot be packed in a container. They can just move around very easily. So definitely you need airtight containers if you want to trap the gas. Otherwise it's impossible. Gases just flow all around. So these are the properties of solid, liquids, and gases. Now coming to the next important aspect here, which we need to discuss, is the properties of water and how water changes its form, right? So water changes its form, which means that water is in the liquid state. Water is in a liquid state, and how can it change to a solid, and how water can change into a gas, provided provided we give them the adequate temperature and other requirements that is needed. So if I say that we have a liquid, say water, and we have to convert it into a solid. So water exists as ice in solid form. So what should we provide it so that water becomes ice? Definitely, we have to provide them with a cold temperature, right? With a cooler temperature. So we will freeze it. And this process is known as freezing. When liquid changes into solid, it is known as freezing. Now, liquid to gas. So we have water, and it changes into water vapor or steam. Water vapor or steam. And this has to be done in the presence of heat. And the process is known as evaporation. So the process evaporation, so it's the name, so it's a noun. I'm just trying to bring English over here. And evaporate is something that is action, so it's a verb. All right, so I hope evaporation, freezing, is all clear to you. I'm just highlighting it with a different pen. What does freezing mean, and how the state changes from one form to the other? So we have discussed freezing, evaporation. Now, there's a reverse process also that we need to understand. How a solid changes into liquid, and what is this known as? So solid in water form is ice, and liquid is water. So it needs heat. And this process, when ice changes into water, we call it as melting. Very simple. Next is when we have a gas and we have to change a gas into liquid. How is this going to happen? So we have to provide a cooler temperature, and then the gas will change into liquid. So steam or vapor changes into water droplets. And this process is known as condensation. and we say it condenses. So whenever a steam comes in contact with a cooler temperature or a cooler, say, object, you can see water droplets getting deposited on it. There are a lot of examples, like, when the water evaporates and we put a steel plate on it, then so, so this is about condensation. Next is melting, and we've already covered freezing, evaporation. Let me mark it with a different color for you, what exactly happens here. So if we do the particle model, we will see how exactly this happens. So since we are concentrating only in water, so which is a liquid, so let me draw the particle model of a liquid. Yeah, okay. So water is a liquid. So let me draw a particle model of liquid for you. So these are the atoms where you see a lot of air spaces also. So as soon as I heat it up, what happens? I heat, then all the atoms, they gain some energy and then they start moving here and there. The arrow shows the transfer of heat to these atoms. Now when they get energized, they start moving. All right, they get so much energy that they start moving here and there, they start colliding, and very soon, in the presence of heat, we will see that some of these atoms will escape out in the form of gases. The atoms are escaping out, and there would be more space here. So that's how liquid changes into gas, and we have proved it also with the help of the particle model, that when we heat the atoms, they get energy and they start moving everywhere, and very soon they get converted to gas. The presence of so many air particles here, air space here, shows that this is now converted into gas. So this process is known as expansion. Mm, because it is getting expanded. The atoms are moving away from each other, so they are getting expanded. Atoms move away. Now next is contraction. Now contraction is something where you bring things together, right? Close together. You contract them, you shrink them. These are the different synonyms. So if we want to do contraction, it's not going to be possible for solids, right? I can definitely contract a liquid to solid, or I can contract a gas to liquid, right? Because there are free spaces. So if I make the particle diagram of a liquid, see, there are still spaces here. So when I provide a cold temperature, they bring the atoms close together, and then they all are stuck like this, and that's how a liquid changes into solid. Similarly, if I talk about gases, they are much widely spaced. And when I again give them a cold environment, a cold temperature, we will see that they have started coming close together and it becomes into liquid. So this is contraction and this is expansion. I hope this is clear to you. The next thing that we need to do is evaporation and condensation in water cycle. So what exactly do we mean by evaporation? When liquid changes into gas, and condensation means when gas changes into liquid. So if I draw water cycle for you, so we have to understand what is water cycle. So water cycle is a continuous never ending process of water undergoing in different states of matter. So water exists in different form. If someone asks you that explain water cycle, so you will say, first let's write down the key points, that water exists as different form on planet Earth, which can be like in solid, liquid, and gas. So if I ask you, what are these forms that you see? So we have snow, we have water, and we have water vapor. And it exists in land, sea, and air, right? So how it exists in land, how it's going to exist in sea, and how in the air. So land, when it's an extremely cold environment, they come down as snow, snow deposits on the mountains, right? Which is actually the solid form. Sea may we have liquid, right? It's sea water. And in air, we have the water vapor or the steam that you see, which is in gas form. So here, let me draw something out. This is sun. Sun rays heats up the water, which is liquid, and then the liquid is going to evaporate and it becomes a gas. All right, so if I draw the particle model, they are widely spaced. Here, the particle model is closely spaced, but not tightly. Now what happens, as soon as it reaches the air surrounding is cooler, right? It's cool. So this gas will change into water droplets. They change into water droplets, and water droplets combine with other gases as well as impurities present in the atmosphere to form clouds. So that's how the clouds are formed. So we see evaporation happening over here, and then we see condensation happening because gas is changing into liquid, right? So here, if I change the color, I'll show it to you. Liquid changes into gas in the presence of heat. Gas changes into liquid in the presence of cool air, and this is condensation, this is evaporation. After this, what happens, that the cloud is going to travel, and when it gets too heavy, it drops down in the form of rain or snow, depending upon the temperature where the cloud is going to burst. So the cloud becomes heavy, and often this is known as precipitation. And now these water are going to come down, it's going to melt, come down in the river, and then slowly get collected into the sea and ocean. So when we see this, it's a whole cycle. It goes from here to up in the air, then back in the land, and then back to the sea. So as you see, it's the whole cycle, continuous cycle, which is getting repeated. This is nothing but water cycle. Now, the last topic that we want to discuss today is about solvents and solutions. So I'm going to take it in the next video where I'll be specifically talking about it. It's going to hardly take 5 to 7 minutes. So thanks for watching. Don't forget to watch the next part of this video, because only then you will be completely revising this topic for exam. Happy learning, guys.